This video we will discuss about the important parameters of analysis of residential heat pump. So, is the heat pump is the application for the second law of thermodynamics, and is the heat pump is the learning objective is the uses of heat engines in heat pumps and its working of heat pump to warm up an interior space and a difference between the heat pumps and refrigerators and heat pumps coefficient and performance. In this diagram, it's explanation about the working principle of heat pump. So the components of the heat pump is evaporator, condenser, expansion valve, compressor, and condenser. So in this image, the heat supplied are in inlet section and the outlet section are there, and the compressor part will be is there. So this is the introduction part of the heat pump with having the components of fan blade, fan motor, condensing coil, compressor, reversing valve, and the fan coil. It's almost having the components of auxiliary heat elements, flower fan and flower motor, evaporator coil, refrigerant lines, condensate line, and filter and water condensation from the air. And after the combining of these all components, the heat pump will be having the some amount of heat loss and not enough to heat and blowing cold air. And the principle of a heat engine is having it is an water heating and it's the distinct heating, industrial heating, and the heat pump is a collector array and it's a pump, it's having a water storage unit and it's the three-way valve is here and the return here and the access unit is here. And thermal relations for this heat pump, it will be having the compressor, the refrigerant to make it hotter on the side and to be warmed and releases the pressure at the side where heat is absorbed. And the heat of the is the deposit is the heat hot suction and heat cold suction. And the heat cold suction is in torque and the heat cold suction, and the inject is the work done. And the components of the heat and pump is the evaporator and compressor, the heat exchanger and the valves, it evaporator and it liquid vapor and separator is the compressor, is a gas cooler and a hot water inlet and outlet section and the expansion valve and the air is an inlet section. So this is the heat pump working section. So his motor is get into the first basic part of the evaporator side, and then it goes to the liquid vapor separator filter section, and then next is goes to the compressor part. Compressor will be divided into mixing of CO2 water heater exchanger, and then finally it goes into the outer valving section part. And after that compressor water, it goes to the evaporating sector in the sector of hot water output side. And the efficiency output of final heat pump is has four main components. Previously, we said that about evaporator, compressor, condenser, and expansion device. And the refrigerant is the working fluid that pass through all these components. And electric energy is required to drive the compressor, and this energy is added to the heat that is available in the condenser. And the efficiency of the heat pump is denoted by its coefficient of performance in the term of the COP. The refrigerant is the working fluid that pass through all these components. So these are the final important characterized output of the heat pump working in engineering thermodynamics. And previously I said that about heat pump is an application of the second law of thermodynamics is the Kelvin-Planck statement and Clausius statement. So the Kelvin-Planck statements and Clausius statements are derivably manipulated, and finally it is goes to the how much amount of input supply we given that is equivalent or not to the we receive the total output part of the supply. And these are the some related links, reference links for the second law of thermodynamics in the terms of analysis of residual heat pump. Thank you.